Hello, dear students. In last classes, we were doing the analysis of 2026 ISC Board Class 12th Board Exam question paper. Uh, we had solved the question paper up to section C. Today, we will solve the problems of section D, that is 15 marks. Now, students, the first question is like this. They have asked, when a coil is connected to a 200 DC supply, the current flowing through it is found to be 1 ampere. However, when it is connected to the 200 volt 50 hertz AC supply, the current is found to be 0.5 ampere. In first part, they are asking explain why current flowing is less when the coil is connected to an AC supply. And second part, you have to calculate coefficient of self inductance L of the coil. So first we will see first part. Students, in DC circuit, only resistance R, resistance R opposes current, but in AC circuit, but in AC circuit, there is a coil, and the coil has first resistance R and inductive reactance, inductive reactance. Because the coil has inductance, so it has inductive reactance. XL, we represent it by XL, and it is equal to omega L. Now, students, so total impedance, that is opposition in AC circuit, is Z is equal to under root R square plus XL square. So, students, because of this additional opposition, due to inductance, current is less in AC. So, this was the solution of first part. They were asked, explain why current flowing is less when the coil is connected to an AC supply. So students, you have to just give the reason. You have to explain why current flowing is less when the coil is connected to an AC supply. And in second part, students, they are asking calculate coefficient of self-inductance, that is L of the coil. So students, we'll proceed for the solution of this problem. So students, as we all know, we will solve second. So, as we all know, in DC, resistance R, it is given by V upon I, according to Ohm's law, and it is equal to 200. Voltage is given 200. Here, if you can see, the voltage is 200 volt, and current is 1 ampere. So, students, it will become 200 ohm. Now, students, in AC, in AC, impedance Z is given by V upon I, and it is equal to 200 volt upon 0.5 ampere, and it will come out to be 400 ohm. So students, we will calculate total opposition, that is impedance in AC circuit, and it is equal to Z square is equal to R square plus XL square. XL is inductive reactance. So now students, here 400 square, it is equal to 200 square resistance R we have calculated, and plus XL square. So students, here XL square, it will become 400 square minus 200 square. Here XL square, it will become 4 4 just 16 and 40 1034 minus 4 and 40 4, and it will be 40 10 20 30 40, and here it will become XL square is equal to here it will become 16 40 minus 4, it will come out to be 12 12 10 20 30 40. And students, if you will calculate XL, then here it will become under root 1 2 10 20 30 40. And students, if you will simplify this, it will come out to be, I am calculating it with the help of scientific calculator, 346.4. It will come out to be 346.4. And students, here, as we all know, XL is given by omega L, and it is equal to 346.4. And students, I can write omega in terms of frequency, 2 pi f into L, it is equal to 346 346.4, which will become 2 pi f. F is given 50 hertz. So here it will become 6.28 into 50, and which is equal to, sorry, into L, which is equal to 346.4. So here L will become 346.4 upon 50 into 6.28, and here if you will calculate it, it will come out to be 50 into 6.28, 314, and 346.4 divided by 314, it will come out to be 1.1. It will come out to be, after simplification, 1.1 Henry. So this is the coefficient of self inductance. This we have to calculate in this problem, and we have calculated, and it is coming out to be 1.1 Henry. Students, this was the solution of this problem. Now we will see next problem. In B part, student, they are asking if the power factor in an AC circuit is 0.5, what is the phase difference between the voltage and current in the circuit? So students, we'll proceed for the solution of this problem. As we all know, if the circuit has inductance, then average power is given by P bar. It is equal to half V naught I naught cos phi, where cos phi is the power factor. This cos phi, it is power factor. And students, power factor is given, that is cos phi is equal to 0.5. So students, we can easily calculate the phase angle phi between voltage and current. So here, if cos phi is 0.5, that is half, then phi is equal to 60 degree. So this is the phase angle between voltage and current. So this was the solution of our problem, that is B part. Now students, we will see this part also, second A. The problem is like this: a 70 ohm resistor. A 70 ohm resistor is connected to an AC source, generating an EMF E, and it is given by 495 sine 100 pi t. Calculate the RMS value of current flowing through the resistor. So in this problem, we have to calculate the RMS value of current, that is IRMS. So students, as we all know, we have studied in our regular classes also. Solution. RMS value of voltage is given by, that is VRMS is equal to V naught upon under root 2, and P, where V naught is the peak value of voltage. So students, here V naught is 495 upon the value of under root 2 is 1.41. So here students, it will come out to be 351.0 volt. So we have got this RMS value of voltage. And students, now we will calculate RMS value of current, that is IRMS, and it is equal to VRMS upon resistance R. And students, we have calculated now VRMS, it is 351.0 upon resistance is 70 ohm. So students, here if you will simplify this, so RMS value of current, it will come out to be 5.0 ampere. So this we have calculated the RMS value of current, and it is coming out to be 5.0 ampere. Now we will see next problem. Students, in B part they are asking, this is also a very simple problem, straightforward, formula based, and we have studied all this in our regular classes also. So students, we'll proceed for the this problem. A 20 centimeter length of a long iron cord solenoid has 25 tons. If the area of cross section of the solenoid is 1 into 10 power minus 4 meter square, you have to calculate its coefficient of self inductance L. So they are asking to calculate this coefficient of self inductance L. So students, we'll proceed for the solution of this problem. B part. So students, as we all know, self-inductance of a solenoid, that is L, it is given by mu naught n square A upon L, where n is number of turns, A is area, and mu naught is magnetic permeability. So students, we will substitute all the values. Mu naught is 4 pi into 10 to power minus 7 Henry per meter. Number of turns is given 25, 25 square. Area is given 1 into 10 to the power minus 4 meter square, and upon length, and length is given, that is 20 centimeters, so we will convert it into meter. So here it will become 20 upon 100 into meter. Students, we'll proceed for next step. In next step, here it will become 4 pi, so 4 into 3.14 into, if you will simplify this, here it will become 5, and students, 5 will go in numerator, so 5 into 625 into 10 to the power minus 4 meter square. So here students, if you will simplify this, here it will come out to be 3.92 into 10 to the power minus 7 Henry. So this is the right solution of this problem. This is the correct answer. This was the solution of this problem. So in next part, they are asking, explain why soft iron is preferred to steel as a material for the core of a transformer. So students, soft iron is preferred to steel as a material for the core of a transformer because it has high permeability, means strong magnetic field, and low hysteresis loss, means less energy loss, and it can be easily magnetized and demagnetized. That's why for this reason, soft iron is preferred to steel as a material for the core of a transformer. तो आपको जस्ट रीजन राइट करना था why soft iron is referred to steel as a material for the core of a transformer. Students, this was the solution of this problem. Now come to question number 19. अब 19 में what we have to do, in 19 you have to draw a labeled graph showing the variation of binding energy per nucleon with mass number A of the nucleus. On it mark the nucleus that is most stable. तो स्टूडेंट्स, ये सिंपल ग्राफ जो है ये आपके बुक में दिया हुआ है. और स्टूडेंट्स, न्यूक्लियाई हैविंग मास नंबर बिटवीन A इक्वल टू 50, A इक्वल टू 50 to A इक्वल टू 80, दे आर मोस्ट स्टेबल. और इनकी जो एवरेज बाइंडिंग एनर्जी पर न्यूक्लियॉन्स होती है वो 8.5 मेगा इलेक्ट्रॉन वोल्ट होती है. एंड स्टूडेंट्स, आपको यहाँ पे दिखाना था कौन सा न्यूक्लियस जो है मोस्ट स्टेबल होगा. तो स्टूडेंट, मोस्ट स्टेबल जो न्यूक्लियस होता है वो Fe56, ये जो है मोस्ट स्टेबल होता है. और इसकी बाइंडिंग एनर्जी पर न्यूक्लियॉन जो है ऑफ अबाउट 8.8 मेगा इलेक्ट्रॉन वोल्ट होती है, एंड इट हैज मैक्सिमम स्टेबिलिटी. तो ये जो है न्यूक्लियस आपको शो करना था डायग्राम में. सो इट इज गिवन इन द बुक, इट इज वेरी सिंपल. नाउ स्टूडेंट, इन नेक्स्ट पार्ट दे आर आस्किंग what is meant by the following statement: angular momentum of an orbiting electron is quantized. So students, this is also very simple. This is from hydrogen atom. And students, uh, Uh, and it is straightforward given in the book also. In permissible stationary orbits, angular momentum of an electron is an integral multiple of h upon 2 pi. H upon 2 pi, where h is Planck's constant, and students, according to Bohr's model, L is equal to mvr. That is, if there is an electron of mass m, and if that electron is moving with velocity v in circular orbit of radius r, so angular momentum is, it is integral multiple of h upon 2 pi, where n is equal to 1, 2, 3. n is an integer, और n को हम क्या बोलते हैं? प्रिंसिपल क्वांटम नंबर. n को हम बोलते हैं प्रिंसिपल क्वांटम नंबर. एंड स्टूडेंट्स, electrons can have only discrete electrons can have only discrete values of quantum number. Quantum, तो इलेक्ट्रॉन्स की जो है डिस्क्रीट वैल्यूज ऑफ क्वांटम नंबर होगी. दिस वाज द मीनिंग ऑफ दिस स्टेटमेंट. So students, in next part we have to calculate the shortest wavelength of Balmer series. So students, we'll proceed for the solution of this question also. So students, as we all know that Balmer series is given by 1 upon lambda, it is equal to r, and to 1 upon 2 square minus 1 upon n square. For shortest wavelength, कैसे कैलकुलेट करोगे शॉर्टेस्ट वेवलेंथ? हम क्या करेंगे, n को इंफिनिटी पुट करेंगे. तो स्टूडेंट्स, हियर n will be equal to infinity. So the above expression will become lambda 1 upon lambda minimum, it is equal to r upon 4. And students, lambda minimum, that is minimum value of wavelength, it will become 4 upon r. Now students, we'll proceed for the next step. So here we'll put the values of r, that is r is a Rydberg constant, 4 upon 1.097 into 10 to the power 7 per meter. And here students, if you will simplify this, it will come out to be 3.64 into 10 to the power minus 7 meter. So this is the shortest wavelength of Balmer series. So this was the solution of this problem. Now next, in the next problem students, the next problem is like this. You have to calculate the minimum amount of energy which a gamma ray photon should possess in order to produce a proton and an anti-proton pair. So students, according to Einstein, if the body is at rest, so it has rest mass energy, and it is given by E is equal to m naught c square, where m naught is rest mass and c is speed of light. And students, in our case there is proton. So students, we have to calculate minimum amount of energy which a gamma ray photon should possess in order to produce a proton and an anti-proton pair. So students, the minimum energy, it will be equal to 2 m naught c square. So students, we will calculate this. 2 rest mass of proton, it is 1.67 into 10 to the power minus 27 kg, and the speed of light is 3 into 10 to the power 8 meter per second whole square. So students, here it will become E is equal to, if you will simplify this, it will become 18 into 167 into 10 to the power minus 13 joule, because this is energy and the unit of energy is joule. And students, here if you will calculate this, it will come out to be, here it is 1.67, and if you will calculate this here, it will come out to be 3.0 into 10 to the power minus 10 joule. So here we have got this. Here it was 167, not 1.67. Here it was 167. So you can check. This is very simple calculation. So here we have got this. So now students, we want the answer in mega electron volt. So students, 1 mega electron volt, it is equal to 1.6 into 10 to the power minus 13 joule. So students, here we will convert 3.0 into 10 to the power minus 10 joule. So here it will become 3.0 into 10 to the power minus 10 joule upon 1.6 into 10 to the power minus 13 joule upon mega electron volt. So joule and joule will cancel out, and here it will come out in the power of 10 to the power 3. And if you will simplify this, it will come out to be 1.75 into 10 power 3 mega electron volt. And here, if you will further simplify it, it will come out to be 1875 mega electron volt. So this is the minimum energy. So this is the correct solution of this problem. Now students, in next part, you have to tell why is a nuclear fusion reaction also known as thermonuclear reaction. तो स्टूडेंट थर्मोन्यूक्लियर रिएक्शन के लिए क्या होता है, वेरी हाई टेम्परेचर चाहिए होता है, 10 to the power 7 Kelvin, एंड स्टूडेंट्स थर्मल एनर्जी हेल्प ओवरकम रिपल्सन. तो जस्ट आपको रीजन राइट करना था. एंड इन नेक्स्ट पार्ट दे आर आस्किंग सिक्स्थ, what is the physical significance of the fact that total energy of an orbital electron is negative? So student, negative energy का क्या मतलब हुआ इलेक्ट्रॉन का? That electron is bound to the nucleus, and second, energy must be supplied to remove it. So this is the reason of this. This is the physical significance of this problem. And in next part, you have to state any one limitation of Bohr's theory of hydrogen atom. So it is very simple, straightforward question, not going in it. You can just see. So now we'll proceed for the next problem, that is problem number 20. So let me upload that. So students, this is a passage based problem. You have to read the given scenario and answer the following questions. So students, Annie, a student of physics, began her experiment by fabricating a PN junction diode from an extrinsic semiconductor crystal, leading to the formation of a depletion region and a potential barrier at the interface. She then measured resistance of the diode in the linear region of the VI characteristic curve. She also studied its characteristics during forward bias and reverse bias. Finally, she designed a circuit to convert AC voltage to DC voltage. So students, this instrument was used by Annie to measure current flowing through the diode during its reverse bias. तो रिवर्स बॉयस में स्टूडेंट्स क्या होती है, करंट जो है बहुत ही कम होती है, बहुत ही लेस होती है. सो स्टूडेंट्स, रिवर्स बायस में हम क्या करेंगे, माइक्रो एमीटर का यूज करेंगे. वाई माइक्रो एमीटर का यूज करेंगे, बिकॉज माइक्रो एमीटर क्या करता है, बहुत ही स्मॉल करंट जो है वो मेजर करता है इन माइक्रो एम्पियर. So students, here we will use micro emitter. And next, how did Annie obtain an extrinsic semiconductor from an intrinsic semiconductor? So students, Annie will obtain an extrinsic semiconductor from an intrinsic semiconductor by doping. अब डोपिंग क्या होता है, डोपिंग में जस्ट हम ऐड करते हैं स्मॉल अमाउंट ऑफ इम्प्यूरिटीज लाइक पेंट्रावेलेंट और ट्राइवेलेंट एटम्स. थर्ड स्टूडेंट, दे आर आस्किंग व्हाट इज मीन्ड बाय पोटेंशियल बैरियर. तो पोटेंशियल बैरियर क्या होता है, इट इज द पोटेंशियल डिफरेंस डेवलप्ड अक्रॉस द डिप्लेशन रीजन ऑफ ए पीएन जंक्शन that opposes the flow of charge carriers. और charge carriers क्या होते हैं, इलेक्ट्रॉन और होल्स. so this is the answer of this problem. And next question, they are asking draw labeled circuit diagram of a half wave rectifier. So students, ये भी बहुत सिंपल है, सिंपल सर्किट डायग्राम आपको ड्रॉ करना था. so I think you will be able to draw. So this was the solution of today's all problems. And if you have liked my problem solving technique, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.